Welcome back, guys. We're going to see some more Nmap scanning techniques and some more options that allow us to do more with this tool. I want to make it clear, though, that this doesn't want to be absolutely a thorough overview of the tool because, Nmap options are so vast and endless that at the end of the day you can write a book, and in fact they did. You see here that they published a book on Nmap, so I warmly recommend you to buy it if you want to know more about the topic, and I think I'm gonna buy it myself because Nmap is a very valuable tool that needs to be in the bag of tricks of any information security analyst, and especially Pentester. That being said, let's see a couple of more techniques. The first thing I want to call your attention on is UDP scans. That's why most scans focus on TCP services, but for you to have a thorough overview of what's running on the operating system, you need to scan UDP ports as well. That's because there are several services running on UDP rather than TCP, like DNS, for example, like Radius or TFTP. So if you limit your scanning only to TCP ports, you might risk to overlook some important services running on the target machine. So you want to have a look at UDP ports as well. Now, there is to say that UDP scans are extremely slow because UDP is a connectionless protocol, as many of you might know. So let's see how to perform a UDP scan and what it looks like in Wireshark. I'm gonna add a timing template too to make this faster. And I'm going to stop the catcher and restart it. We had no positive result on our target machine, our Metasploitable 2. Probably we don't have any services running on UDP, or anyway we have a problem reaching UDP ports on this machine. But like I told you, UDP is a connectionless protocol, so it doesn't have any sort of flow control like TCP has. Alright, so we're going to abort the session and we're trying to attempt that on a real world target. So our scanme.nmap.org, sorry, but I don't remember the IP address, so I'm going to look it up here because I can't do it in my Kali machine as I'm using a net connection here. Alright, so I'm going to stop the catcher and use another interface here, the ATH0. And there you go. You see that we have a service running under port 123 UDP, which is NTP, or that is Network Time Protocol. You should see UDP here. Alright, so that stresses how important it is to check both TCP and UDP ports. Now, if, say, the service had a critical vulnerability and we didn't scan UDP ports, we would have missed an important way for us to hack into the system. The same line of the TCP Connect scan and of the UDP scan, we can have the SCTP init scan that uses the SCTP, which is the String Control Transmission Protocol, defined by this standard here, RFC 4960, if you're interested to have a look at it. Those documents are really important and you should know them, thoroughly if you want to hack systems. I'm not very good at reading documentation, but I do it if I have to. Anyway, let's have a look at how it works. It's a very fast type of scanning that practically goes around restricted firewalls and is pretty stealthy, so it can be an advantage. It also provides a reliable differentiation between open, closed, and filter states. So let's have a look at it. We only need to replace the U with a Y. For time constraints, I'm going to keep this real world target as our target, so it's not a big deal because we have permission to scan this website, so I'm not going to run into any sort of trouble. So let's see how it works. Absolutely awesome. You see it was 0.16 seconds, and it says all ports are filtered, which doesn't help us a lot, but anyway. Alright, now we could perform these scans here, which are the null scan and the fin scan, but pretty much we saw them when we performed the Christmas scan, which pretty much performs all of them at the same time. I could perform this one, but I already know it wouldn't work in this case because we're attacking a Linux machine and not a BDS machine. And BDS derived systems are, for example, Macs. So it could probably work with a Mac, but it won't surely work with a Ubuntu virtual machine as Metasploitable is. Alright, let's see some couple of advanced options here, and I'm gonna leave the scripting engines for another video. We've already seen the P option. I like the option -P- instead of specifying manually 1265535 because it's the same thing. You can also specify a smaller range of ports if you think to know what kind of services you want to look for. You can also exclude ports and so on. What I like to show you is a couple of things, especially this one, version detection, and I want to go into operating system fingerprinting. So let's start with the version detection. You see that we now have the version installed of OpenSSH and the Apache version. That allows us to determine if there are any vulnerabilities we could use against this virtual machine. Now, for example, if we copy this here and we plug the stuff into browser and we go to Offensive Security Exploit database, we can check if any vulnerability exists with reference to these versions here. Okay, you'll see that there are several vulnerabilities we could exploit. Some of these are very recent. This looks pretty serious. And I'm pretty sure if we look in the Metasploit framework, some of those has been ported to Metasploit. But that's something we're going to do in a coming video when I'm going to try to attack these vulnerabilities to exploit the system. So you understand how important Nmap is for reconnaissance purposes. Another thing I want to show you here is operating system fingerprinting. Now we're going to add this capital O option that allows us to perform the operating system fingerprinting, and it should give us a plausible identification, hopefully, of this target machine. So let's see how it does. You see that Nmap returns a series of guesses, and very likely we're dealing with a Linux machine. Now we can have another confirmation about this by using a different tool, Netcraft. Now if we go here, that might give us a plausible identification of the target machine. Looks like it's running Ubuntu, probably a Ubuntu server version, but sometimes this type of identification is not 100% reliable. So that's a tool that you can use for reconnaissance as well. I want to point out here that Nmap is practically based on the ICMP protocol. It practically performs a ping request on the target, so it works only if the target accepts ICMP packets, otherwise we won't have any message back. Another option you might want to use is PN that skips host discovery. It supposedly use to make your scan faster. You see that it's a little faster here, and we have a series of open ports, by the way, and some filter ports. You notice we have SSH, like I said, HTTP, which makes sense because we could reach the website. And this one, which I don't really know what kind of port is related to. Just want to see it out of curiosity. It was used by a series of old Trojans. But I would bet it's probably some administration tool. Okay, this is quite interesting. Anyway, that's all for this video. Next time we're gonna start seeing some scripting, and we're going to have a look at we're gonna have a look at Nmap scripting engine here. That's much more powerful than the options we've seen so far because it allows us to achieve much more automation in our results. Okay, so we're gonna see each other in the next video, hopefully, and until then, have a nice day. Bye bye.